Let's solve the following trigonometric equation. We're given the sine of 3x is equal to a negative 1/2. We want to find the x values in the interval from 0 to 2 pi that make the left-hand side equal to a negative 1/2. All right, first thing you want to do is recognize the sign. The sign value is negative or less than 0. And what this tells us is that our answer is going to lie in quadrant 3, and another answer will lie in quadrant 4. So we'll keep that in mind as we solve this trig equation. All right, so the first thing we want to do here is isolate the 3x, and we're going to undo the sign by taking the inverse sign of both sides. So taking the inverse sign to the left will leave us with simply 3x. On the right, we'll have the inverse sign of a negative 1/2. All right, and from your calculator, you can see that you end up with a reference angle of pi 6. And the way we'll have to write this in the fourth quadrant is a little bit different. So let me label this. We're going to start in quadrant 4 because that's probably what your calculator told you. In quadrant 4, the inverse sign of a negative 1/2 is going to give you a value of 11 pi 6. And note that that is equal to 3x. We have to address the periodicity of the sign, knowing that the sign has a period of 2 pi radians. And the way we do that is by writing 2 pi n added to our 11 pi 6. And this will address the infinite number of angles that satisfy this equation. More on that later. Let's solve for x completely. We're going to divide both sides by 3 here. And from this, we end up with x is equal to 11 pi 18ths. And then that's plus 2/3 pi times n, where n is any integer that we can think of here. Now let's think about quadrant 3. In quadrant 3, again, our reference angle is pi 6. So we can also say that 3x is going to be equal to 7 pi 6 in quadrant 3. Again, addressing the periodicity, we're going to add 2 pi n to that value. As before, we divide both sides by 3. So from this, x is then equal to 7 pi 18ths plus 2/3 pi times n. So these are the infinite number of solutions in both quadrants 3 and quadrant 4 that satisfy this trigonometric equation. Now we have to address the fact that the problem wants us to find those solutions from 0 to 2 pi radians, and we'll do that by plugging in values for n. And we'll start with n equals 0 for this particular problem. So in doing that, 0 times anything makes that disappear. For n equals 0, we have x is equal to 11 pi 18ths. When n is equal to 1, adding those together, we end up with another solution of x is equal to 23 pi 18ths. And finally, if we add n equals 2 there, we're going to end up with x being equal to 35 pi 18ths. And those are the 3 solutions from our first answer, x equals 11 pi 18ths plus 2/3 pi n. Now, part of the reason that we don't go any further than this is if we plug in n equals 3, that will move our solution outside of our interval. Okay? In a similar fashion, we're going to focus on the second equation, and find those values for when n is equal to 0, 1, and 2. And you can verify this independently, but if we solve this equation, plugging in 0, 1, and 2 for n respectively, we end up with values of 7 pi 18ths, 19 pi 18ths, and then also 31 pi 18ths. So these are the 6 solutions in the interval from 0 to 2 pi of the trig equation sine of 3x is equal to a negative 1/2.